All right, guys, so I've got a problem here where it says let matrix A equal 4, 2, 5, negative 8, and B equals negative 2, 17, 3, and 0. And we want to add these to find A plus B. So A plus B is really, we're going to write them in that order. We're going to have the matrix of 4, 2, 5, and negative 8 plus negative 2, 17, 3, and 0. Now when we add our matrices, we're just going to do element by element. So my A sub 1, 1 right here, we're going to add that to my B sub 1, 1. And it's going to give us the same size matrix. So what I would do here is I'm going to do 4 plus a negative 2, because we have 4 and a negative 2. Now my next element is going to be 2 plus 17, because we have 2 and we have a 17. And then on my next row I'm going to have a 5 plus 3 and negative 8 plus 0. And then from here it's just basic addition. So when 4 plus negative 2 is going to give me a 2. 2 plus 7 gives me 19. 5 plus 3 is 8. And negative 8 plus 0 is negative 8. And now our matrices are added. Pretty straightforward. It's just element to element. So A sub 1, 1 to B sub 1, 1. A sub 1, 2. A sub 1, 1 plus A sub 1, 1. A sub 2. Wow. Let's try this again. A sub 1, 1 plus B sub 1, 1. A sub 1, 2 and B sub 1, 2. And we just keep going all the way through. Now it's very important to understand that if you want to add matrices, they must have the same order. So if we look at the order here, there's 2 rows and 2 columns. So this is a 2 by 2 and this is a 2 by 2. You cannot add a 2 by 2 to a 3 by 2. That would be undefined by definition. Very, very important. Subtraction works the same way. I don't think I need to make a video on the subtraction part because you guys have been adding and subtracting. You are seniors in high school, juniors or sophomores as well. But you've been doing that since at least 2nd or 3rd grade, so I figure you guys can add or subtract. The next thing we're going to go on to is multiplying by a scalar. We're multiplying by a scalar. You've seen this before, but really what you've seen before with it is what you've actually seen before when you're multiplying by a scalar is like 3 times 4x plus 9, and you distribute this 3 to everything in there. So this would have given you 12x plus 27. Really what we're going to go ahead and do when we multiply by a scalar is, it's going to be the same concept. We're going to have a number on the outside to multiply a matrix, and it goes with everything inside a matrix. So, if we have a matrix A, and matrix A is 2, 8, 4, 4, 3, 9, 0, and 1. And I want to go ahead and find 2A. All we simply do is we do 2 times my matrix, which is 2, 3, 8, 9, 4, 0, 4, 1. And then from there, we are going to just basically distribute the 2 to every single thing in each row and each column. So this becomes 2 times 2, 8 times 2, 4 times 2, 4 times 4, 3 times 2, 9 times 2. Why did I do 4 times 4? 4 times 2, there we go. 9 times 2, 0 times 2, and 1 times 2. And then we just multiply at that point to get our answer. 2 times 2 is 4, 3 times 2 is 6, going on. And this would be your answer to 2A. So multiplying by a scalar with matrices is really, it's essentially like multiplying say a linear equation with a number in front using the distribution property. We don't call it the distribution property, we call it multiplication by a scalar, but it really is the same concept. You just know that it's got to go to everything within the matrix. On the next video, we're going to go ahead and talk about how to multiply matrices to matrices. Now, of course, you can do all types of different things, such as like we can do like 2a plus b, things like that. So really our order of operations still are going to hold true to matrices. But some properties will actually start falling apart. You'll see that when we start multiplying matrices.